Let's solve this problem here. Write E is the set of x's such that x equal to a squared plus 1. And a is an integer and -3 is less than a, and a is less than or equal to 2 in roster notation. So we'll write this notation in we'll write the set in roster notation, list all the subsets of E. Now let's start with this here. This x here depends on a. So what is a? So it says a is integer and it has this property. So it means a should be -2, -1, 0, 1, and 2. So in this case, x is equal to -2 squared 1 plus 1. Okay, first let me write the formula. So for this one, I have this. So here we get this. One, 2, and 5. So this is the set. Now the subsets of E are empty set 1, 2, 5, 1, 2, 1, 5, 2, 5. And 1, 2, 5. So this is the answer here. Now let's look at this problem. If a is equal to the set of x's such that x is an integer whose square is equal to itself, and b is equal to -2, -1, 0, 1, 2, and it says list all the subsets of a intersection b. First, let's find a. What is a? So what does this mean? X is an integer whose square is equal to itself. It means x is an integer, and x squared is equal to itself. So in this case, when you solve this one, it's obvious that x can be 0 and 1, and it's integer. So 0 and 1 is okay. So a is 0, 1. Now when it goes to b, b is -2, -1, 0, 1, 2. So in this case, any intersection b is 0 and 1, and the subsets of a intersection b are empty set 0, 1, and 0 and 1. Okay, let's simplify this expression. Now look at the big groups here. So we have some groups, one group in brackets, the second one, and we have the third one here. And inside the brackets, we have these groups here, this multiplication here, and we have another group here. This is another multiplication. And so let's do this first. Okay, if you have two-term binomial times binomial, do this first before that one. So then you got negative x squared minus 5 squared. So you can also do this, anyway. So it will be from the special product. Also, you get x squared minus 5 squared, and then minus x times. Okay. You can, if you have a number here, just one number, polynomial or no binomial, you can do this. You can start with negative 3, and then x, negative 3x, and then plus 6. Sorry, it will be plus 6. And then here we can do also this. We have one term here. You can multiply them then. Plus, okay, negative 12 plus 4x. Okay, now let's see if there's any cancellation inside. So this is negative, positive, so it will be 25. This is negative x times 3 plus 9, 6, it makes 9. 3x minus 12x, 12 plus 4x. And here you can combine these two, so it will be 27 minus x squared. And negative 9x here. And then this one here. If you have only one term here, as I said, you can directly take this sign and multiply with the signs. So it will be plus 3x squared, and then negative 12 plus 4x. And then let's do this one also. 81 minus 3x squared, negative 9x plus 3x squared minus 12 plus 4x. And then we add the similar terms. We simplify them. So they cancel out. And here this one and this one, they will make negative 5x. This 81 and negative 12, it will make 69. So this will be, the final answer will be negative 5x plus 69. Okay, now it says evaluate here. Indeed, we want to write it as okay, another way to say it, write this expression, write it as a single fraction. So this is what we want from you here. So what is wanted from you is this. Okay, now we have to do the fraction here. First, let's start with this part. 2 minus 3 over 4 to the negative first power. Okay, one thing is here the inside is like 2 over 1 minus 3 over 4, and then negative first power. So how do you subtract these two? We multiply this with 4. So you multiply both numerator and the denominator with 4, so it will be 8 over 4 minus 3 over 4, negative first power, so which is 5 over 4 to the negative first power, which makes 4 over 5. Now, when it goes to the, okay, when we come to the other one, we see this 3 plus 1 over a is equal to 3 over 1 plus 1 over a, which is a. So you can multiply 3a over a plus 1 over a, so it will be 3a plus 1 over a. Now we have this one here now, 4 over 5 here, 4 over 5, and this whole thing is 3a plus 1 over a. So what's the last answer? So it will be then 2 minus 3 over 4, negative first power, divided by 3 plus 1 over a is equal to 4 over 5 divided by 3a plus 1 over a. And this means 4 over a times a over 3a plus 1. And then this means 4a divided by 5 times 3a plus 1. You can write it this way, or you can write it as 15a plus 5. Now, one important thing here is, okay, this is the final answer, and there's a common mistake here, Like when someone says 2, 1, negative 1, so it says 2 to negative 1, 1 to negative 1. So this distribution is a common mistake. So you cannot do this. Okay, this is a mistake. You cannot distribute the power to the inside in a fraction, in a subtraction. Never do it. Okay, let's try to simplify this or evaluate. This is negative 2 over 3 cubed. Why? Because if you have some number here, and if it is an even number, so you write this a to the n, and if n is even. So if we have an odd, then it's negative a to the n. So we have this one. It's 2. So what is this? 2 plus 1 over 4. Eight over 4 plus 1 over 4, so it's 9 over 4. So we can write here it's 9 over 4 times negative second power. So here you can distribute them 2 cubed over 3 cubed minus 2 times. So what does this mean here? This means you can write it this way. That means four over 9 squared. 4 squared over 9 squared. So this will become 8 over 27. And this will be, if you calculate, this will be 32 over 81. So how do you make them same? The common denominator. So you multiply with this 3. It will be 24 over 81 minus 32 over 81. And this together, it will be negative 58, 56, divided by 81. You can simplify if you like, but I'm not sure if it is simplifiable. No, there is no common factor between them, so we cannot do it. Now let's look at this problem. Okay, simplify this expression, and here there's a condition on x and y, so this is very important. If you have the absolute value question like that, this is very, very important. Now first, so we have to deal with this absolute value. So this is the main problem here. So what are they equal to? So if you figure this out, then it's easy. Now, let's remember this, okay? Okay, remember. So let's remember the formula for the absolute value. So, you know, in mathematics, we have a rule of everything. We have the math is a rule, the science of rules. So it's a and negative a if a is positive. So if a is negative, so then it's negative a. So let's look at here. This one, this is positive. So if a is positive, then you write it as it is. If it's negative, then you do this negative 1. So it's a is this one here. So you put it here negative, it makes plus. So here our goal is now this. What is x? So what is the absolute value of x? So here the question here is negative. Is it negative or positive? So we have to answer this question. So if we answer this question, we can apply one of the rules here, either this one or this one. Now, here we check this condition. It says x is less than 0, so this means x is negative. If x is negative, then the inside is negative, right? X is negative, so which rule should we apply? So in this case, if a is negative, we multiply it with minus, right? Negative sign. So it's negative x. Now let's look at the other part, the other term with the absolute value. So the other term, the absolute value with the absolute value is y minus x. So here comes the question. This one here, y minus x. Is it negative or positive? So how can we answer this question? So again, this condition tells us x is less than 0 and 0 is less than y. So what can it say? So it means y is bigger than x. So you can say y is bigger than x means y minus x is bigger than 0. Okay, that's one way to do it. It's y minus x is bigger than 0. It means y minus x is positive. And if the inside y minus x is positive, then you don't put any negative here. You just write y minus x. Okay. Or if you didn't understand how this goes, how this happens, one other thing is here. So you can check this out by picking some numbers. You pick minus 1 and pick 1 here, and then y minus x will be 1 minus minus 1. So here it will come to this 1 here. And then you have 2. 2 is bigger than 0. So you can say for these choices of x and y, it's bigger than 0, so y minus x is positive. Anyway, so in this case, we got what we wanted. So now we solve the absolute value issues, then we can go ahead and do the multiplication and find the answers. So the x times negative x, negative y times, okay, here for this one, we want to write it in absolute, in parentheses all the time. If you have binomial, you have to multiply with something, put in parentheses. This is important. Again, this is very, very important. The parentheses are very important. If you don't put them, it will lead you a mistake. Now when you do this multiplication, you get negative x squared, and if you have one term here, one term, and a monomial times a binomial, so you can multiply with the signs, with their signs also, so it will be negative y squared, and then this one plus xy, and then x squared plus y squared. So then, is there any cancellation? Let's see, negative x squared plus x squared, cancellation, negative y squared plus y squared, cancellation, and then we end up with xy. Okay, let's look at the other problem here. We have another absolute value now. So we have this absolute value and this absolute value. Now for this absolute value, since we are dealing with the numbers, these are all numbers, no x in it, so you calculate this one, directly calculate. This is 9, and this is 4 times 8 divided by negative 2, which makes negative 4. And okay, for now, let's keep it this way. And this one is 9 minus 16, and this is negative 7. And what's the absolute value of negative 7? It's 7. Okay, so we solved this issue. Now let's look at here. So 7 minus x. So the main question here is it positive? Is it positive or negative? This is the main problem here. Okay, how will we know it? So it gives this condition here again. So x is less than 0. So what does this mean? If x is less than 0, x is negative. So 7 minus x, so you had a negative value, so you 7 minus, for example, pick minus 1, what do you get? It's 8. So it's positive. So you can say it will be positive if we have a negative number. So we reach this conclusion here, it's positive. So here, this is positive. You know, it's positive, you know, check it, like, because we use this condition, x is negative, you put a negative number here, so it makes positive. So you say positive. If it is positive, what do? We just don't change this. 7 minus x. So we solve this one. Now we can put this here. So, okay, always remember this. Okay, we put them in parentheses here. Don't forget the parentheses. So if you want to write this here, you put them inside the parentheses. So this parentheses, negative times, okay, you distribute, it will be plus x here, 7 minus x plus x. So then we end up with the solution x. So this is the final answer. Yes, now this time let's write this in standard form, and we will determine the coefficient of x. First, let's deal with, okay, we have products here, so we will do the product first. Okay, let's distribute this negative x times negative x over 3. You can say x times x squared, and this will be 3, and then x times negative 4, so it will be negative 4x, and this will be x times x squared, so it will be x cubed. Now when it comes to here, it's indeed, you can write this one as x plus 1 times x minus 3 or 1 here, and then multiply, and then you can combine them. I mean, you can put them in the numerator, and then after you do the expansion here, you will get x squared negative x plus, no, negative 3. over 4. So I will write this one here, but be careful here. So this is important. If you have minus here, then put them in parentheses. Okay, this is important. So x squared minus 2x minus 3 over 4. Now, then when writing the polynomials in standard form, you should try to separate all the powers of x. Like you have x squared here, so you have to separate. So it's, I will write this one as x squared over 4. I will write it as one individual term, so 2x over 4 and then negative 3 over 4. Then I can deal with this negative sign here, minus sign. So then I distribute the negative x squared over 4 and then plus 2x over 4 plus 3 over 4. Now I will try to combine the similar terms here. We have an x squared and we have another x squared here. So how will I combine them? Okay, so they will make what? Okay, then I'll combine and write them here. Okay, I will do it here. Negative x squared over 3 with x squared over 4. I multiplied 4 and 3, and then I got negative 4x squared, 12, minus 3x squared over 12, and then combine them because we have same numerators. So it will give us negative 7x squared over 12. So this has to be negative 7x squared over 12. Now, let's look at this term here, negative 4x plus 2x over 4, and let's do them here again. You can write it as a fraction, then multiply, and you will do the rest. This will be 16x over 4 plus 2x over 4, and then negative 14x over 4. So you can write it here. And now it comes to plus x cubed, this one, and now this one, 3 or 4. But be careful, this is not in standard form yet. Okay, to get the standard form, you have to write the terms in an order. So you should write the powers, okay, in descending order. So in this case, you have to change the order of the terms. So you start with the biggest power here, it's plus x cubed. First one is plus x cubed, and then what is next? It's x squared power is this one. I mean x squared term is this one, so you write the second x squared. And now the third one with x, so it will be negative 14 x over 4. And then the last one is the constant term. So this here, so 3, 2, 1, you know, it goes this way. This is standard form. So the powers should go in descending order. So in this case, this is standard form. And what is the coefficient of x? So the coefficient of x is definitely this term here, and this is the coefficient of x is Okay, the coefficient of x is negative 14 over 4, or you can do the simplification. It was negative 7 over 2. Okay, let's look at this problem. Find the integers a and b such that this division is equal to 2 to the 8 and 3 to the b power. Now, first you have to deal with this one. Okay, let's do it. It's 4 divided by 3 to the negative first. So it will 4 over 1 over 3. And you can write it as 4 divided by 1 over 3. And you know what to do if we have two fractions divided. So you flip the second one and multiply with the first one. So it will be 12. So indeed, this guy turns out to be 12. 3 over 2, negative third power means 1 over 2 over 3 to the cube. So this is 1 over 2 cubed over 3 cubed. Then you can flip it, 3 cubed over 2 cubed. Since it's asking the power, so it's better we keep it this way. So you can write also 27 over 8. And this one, no need now, no need. Because we want the powers. So now we know everything about this. So we can put the substitute what we found in the formula. It's 12. This is 12 squared divided by 3 cubed over 2 cubed. Okay. So this means 12 squared times it will be times 2 cubed over 3 cubed. Now we will try to write it as the product of the powers of 2 and 3. So here we can do it this way: 12 times 12. Okay, I will combine them, like I will put the 1 here and then I will multiply 12 times 12 times 2 cubed over 3 squared, 3 cubed. Now, this here is, you can divide by 3, so it will be 3 squared and it will be 4. And you divide by 3 here, so you will get 3, and here you will get 3. And so this will be 4 times 2 cubed over 3. And you can write them as like 2 squared, and 2 cubed divided by 3, and this will, okay, you can add them, 2 to the 7th power of 3. So the question here is, how can you write 2 to the 7th over 3? You can write it like 2 to the 7th times 1 over 3, and this will be 2 to the 7th times 3 to the negative first power. So then A is 7 and B is -1. Okay, let's look at the last problem. We will try to simplify this. Now, the first thing is we have to deal with the 4th power, and here's the cube. And the question here, shall we do it this way, like A times B and B divided by 3, the 4th power? Okay, taking the 4th power of this, it's very huge. And it will not help our solution. So it's better, I mean, maybe for the simplifications, we have A plus 1, we have A plus 1. So it's better we don't do the distribution. So don't do it. So it's better to keep it there as product. So what's the rule for this? Okay, the rule is you can separate, you will separate 4, you will distribute 4 to the numerator, and denominator. Now for this one, you can do the same thing. And for this one, we have 3. So here 1. You take this one as 1, you know, like the first power, so you multiply with 3, so you get 3 here. So this is 3 to the third power, and 3 times -1, it will be b cubed. Okay, one mistake here, one common mistake. Okay, don't do this. No, this is not true. Okay, don't do this. Okay, they are all in multiplication, and if there is some cancellation, now we can do it. Now this will be okay. Then I can, since it's all multiplication here, and these are the fractions, and I can separate the variables, like this one here. I can I can change their places, and here it will be 3 cubed over 3 to the 4th, and b to the 4th, and b to the -3rd, so it will be b 4 plus -3, and we'll end up with, okay, what is this equal to? This the bases are same, so we can write them as 4 minus 3, and here 3 cubed over 4, 3 to the 3 minus 4, and b, it will be 1. So we have a plus 1 times 3 to -1st power times b. And if they want it, okay, if someone wants it as a fraction, you can write it as a plus 1 times b divided by 3. So this negative, okay, 3 to the -1st power, okay, remember it's 1/3. So the answer will be this. So you can also multiply, it depends on what is wanted from you at the end. It's an open-end question, and it's not a multiple choice. You can leave it as it is. It's understood. Okay,